Morning all. I'm You'll notice that this video that I'm making now isn't a representative of what we actually did in class. Reason is I changed my screen, gone through changing my screen, and for some reason yesterday I say for some reason, it's basically redefined itself, and it actually ended up just recording. See where my zoom icon is up here? It just recorded that with all the voices, and so I've had to delete the whole thing. But what I thought I would do is take you through exactly what we did. You will have to get in touch with me. I can help you through any issues, but I want to try and explain the lines that we added. So I'm going to open up the original, and you'll see that this is the original set of notes that we did. As a reminder, we've got our variable declaration area. Then what we've got is we've run into them as submain. We've got the application, dedication, and so forth. And then what I wanted to do is I wanted to introduce O-rings. Now I'm just going to bring up the image that we were referring to because it is quite useful to see it. So this was literally me just finding something off the internet for me to take a look at and try and map against, if you know what I mean. Now this one's a good one. So 2 seconds, let me just open this. If you take a look at this, you see here we have different lengths, different widths, and under different widths, lengths, we've got a single O-ring or we've got a double O-ring. Now, what we're essentially trying to do is not map this completely, not replicate this completely, but look at rebuilding something that gives us a similar representation, because then once we have that similar representation, we can then elaborate on this further and we can do more with it. So if I just pan this back, this is the original code. Now, what we were looking to do is, just add this in. We were looking to add in further elements to it. Now, you'll also notice yesterday what we did is we made this path. Now, I'm just going to record the process of how I automatically got this again, just because I do think it's important that you know. So I added this in, and this is my new part. Now you notice here it refers to a position. This position is actually the templates. Now for those of you who may not have been listening yesterday, what they do is the template is a key refined within it. It has geometric referencing, it has layouts, it has structures to it, it has a lot of important elements to it. So what this does is it reads from it and then uses it as its base way of assignment. So if I just bring this back on my normal open screen, what I can do is hit record. Now it's as we know from a keystroke, it records everything as normal. If I go to new, brings up my normal template selection system. Now you notice here that they've got so much more extra. For those of you who don't know, you can actually make your own template. So it brings up your company logo, and it just looks very, very professional. So if you're a company and you want people to remember who you are, you can always use that as a baseline. So if I click OK, so it brings it in as normal, and then I don't do anything else from this point. I just hit stop, and I'm just going to put it into my favorite file tab, dummy. I always have these dummy tabs, so I always know that's where I'm storing the last bit of crap that I recorded. So in here, I just go to edit, and I'm going to edit my dummy. So if I snap this right back, you'll see here, this brings that raw data. Now what I did from there was simply, I mean, we know we don't need these, we know we don't need these. However, if you ever get to this point, you kind of look and go, do I need it? Do I not? Copy the whole thing. So I copied the whole thing across, and when we come into, apologies, when we came to here, what I did is I simply pasted it all in and then just looked to see if there was anything identical. Now the one thing that was identical is this one, set part as active document. And what I ended up doing was deleting that out, because you kind of look and go, do I need it or do I not? If there is a double, then you definitely don't need it, so you delete it. Also, you'll notice I commented this out. This is because all CAD systems like to increment the amount of parts that have been generated. Now, by me commenting that out, it's me just saying, look, I'm not interested. You keep counting, count as much as you like. I actually just want to use that baseline. Now, the reason I was doing this is because I was going to loop and I wanted to run it again. So you'll notice here as well, I moved my start upwards to above the SolidWorks application declaration. And when we were down here, this is all what we did last week. When we were down here, you'll notice that this is where we had the input, and I've said go to start. So now, if the user clicks that they want to go to start again, what it'll do is snap it all the way back up. Oh, apologies. Right, apologies for that. Somebody came to my door. So there was some extra things that we added as well. So we did the new part, we added that in. Again, you will need to take a look through this, and I can try and guide you a little bit more. Apologies about the miss in guidance with this, but it's one of those things that I just could not help. Now, the extra thing that we added was this. And if you remember, this is the O-ring, but I should really say it's the sketch. Now, this sketch moves along the fixed length shaft. And what you can see here is that the standard length is divided by 4 to give it the first half for position, and then the second position is based on apologies, 2 seconds. So again, this is the position of the circles. Now, positioning circles, as I was saying, this is the first position of that circle. Now, normally what you've got to do is position the center of the circle and then draw the radius from that circle along a position. So you notice here, this is the starting point of that circle, and here is the starting point of that circle plus the radius that we defined. Now, I defined this as a fixed radius for the O-ring, if you remember, where we're using simple values of 1 millimeter and 2 millimeters. And all this does is this moves along the X but holds the same position as, holds the same position as Y. Now the second circle sits same position again, but I multiply that by 3 to jump them all important 3 positions along. And then what it does is it then apologies, that's the starting point, and then repeating the same process, plussing that O-ring, gives it a second position, giving us this type of positioning like this. So then what we did is we looked at introducing that, but then I threw a curveball in. What if we're then in a position where we don't want 2 O-rings? What if these are the same brand, but we've got 1 O-ring here and 2 O-rings here? What could we do? Now, everybody noted rightly yesterday, if statements would do this really well, which, again, is absolutely great. And I also made up, I came up with a method for defining distances as well. So what I mean is, if you remember yesterday, we were setting shaft distances. Now what I said is I used a case statement. Now the all important thing with a case statement is that when you have a case, you can actually test thousands of variations. In this, I only tested 2. So I just said anything that's greater than 10, make the standard length this, make the NR, which, what did I call NR? Number of rings equal to 1. And if you notice down here, NR was equal to 0. So basically I was saying if anybody puts in anything more than 10, NR will be equal to 1. So it's going to put on 2 rings. Anything less, and what it will do is it will make NR equal to 0. And then it will give us a way to interface between these 2. And then from there, what I did is I tried to be a little bit more slick. if anybody was going to choose a radius, so if it jumped in at 10 and anybody had a radius at a certain size within that 10 parameter, what it would do is it would set a wall thickness which was scalable to the size of that radius. And again, that's me making it up. There was no factual content behind that. But this is a way of being able to have multiple options jumping around, if you will. Now, what I didn't note, well, what we did note is that if we were going to have two different types of O-rings, so in this case, we've got circular O-ring, we've got like a rectangular O-ring here. What we needed to do was to have multiple options within it. So if you look here, if NR is equal to 1, then we set this as an O-ring. Else, if NR is equal to 0, then we set this O-ring. Now this O-ring here, you'll notice, is only one drawing, is only one corner rectangle. Now that's because we're positioning that once. Now the issue is when we jump into this, a circle, two circles in a line, means that there's hardly any lines that's in there. So as we know, these systems like to count how many lines are in position. So it's a good point of reference. So if I scroll up this here where I've said line 2 and line 7, line 2 is an example of where there are circles. Line 7 is because it's a corner rectangle and you end up with so many extra lines in that drawing. So what we did is we knew that if we needed to draw in circles, we needed to be able to select line 2. We knew if we were drawing in rectangles, we needed to be able to select line 7. And it kind of sat there and gone, oh hell, how are we going to do it? So what I used is a floating variable. These are good within a module. Do not ever try to use these to jump in between functions, because if you jump into a function with a floating variable, it loses what it's been assigned. So you jump across and go, what do you mean it's 0? What do you mean it's not working? That is a huge pain in the backside. So what we did is we declared it here because we knew we were free to do that. So if I scroll back up, you notice here we've got ln, and then it's been defined with line 7 or line 2. So if I jump through, what it will do is it will set that to jump to select the right one, and it all runs into the same logic here. Other thing I do want to point out, and I cannot stress enough, indentation of your code. If you do not indent your code, it's the exact same as if you're writing your final thesis and it's one giant paragraph. It's very poor and it's seen as very shoddy work, so please do make sure that you do it. Right, so if I scroll back up, again, you will have to get in touch with me if you have issues, just because I appreciate of that. This isn't the recording that we did yesterday. It was something went wrong for me. So, excuse me. So you'll notice here as well, I'm able to actually, I've done all of my checking in meters. So as long as you stay consistent to the meters that the units that you're presently in, it won't be a problem. So I do all my checking here, and then what I do is come to my units area, and when I drop out, when this drops out, it drops straight into here and converts everything that needs to be into the relative units that I'm using. And the other thing is we did set, the week before, we set a test about R being less than equal to SR. Now what I mean is the standard radius against the radius from the input from the user. Originally this was set to go to start. What this would do if I left it at the start is every time somebody got that wrong, it'd make a new part. If they got it wrong 10 times, you'd end up with 10 parts floating on the screen, and it's a bit crap. You get a lot of people who just go, what? So what I then decided to do was to define another marker. So you'll notice here I've marked up as go. So basically, they put the units in, we do R as a check, and then if they get it wrong, or if something goes wrong, it jumps them back to go, and then they start the whole loop again. And that's just basically using an if statement with a less than or equal to character. It's really, really useful. There is further things with this. I'm trying to think anything else that I've missed off. I mean, I'm going to do another session today based on very much what we've done here, but in a different tool that we're going to be making. But this just allows people to see exactly the modifications that we made. Apologies that the recording did not work like I wanted it to. But I just thought we could have a quick review on that. The other thing is the notes. Now the notes I've been using are working with data types. So these are the data types, and there is a little bit on here about templates. And we started to be introduced to something which you might not have all seen yet, but this is a while loop. We will be jumping into whiles, fors next week, but this is just to get you guys to be able to look at it and get an idea of what's happening with it. The other thing is, there is, as ever, as I like to do, as I'm really liking to do, there is challenges. For those of you who did the challenge last week and those of you who sat through that challenge yesterday, I'm going to re-record that today because obviously that was a big section, and I do want people to get used to moving stuff around. Don't forget, my solution is only one of possible thousands of ways of doing it. This has been one of the best solutions I've seen, and it wasn't me that originally came up with it. It was actually a student who looked at one of the solutions I was originally doing and said, could you not do it this way instead? And it was just a genius idea. I loved it. So I actually run with that one. But again, I'll do that recording in today's session, which will be 2B. Challenge-wise, this is a case statement. There's a few things for you to have a go at. Operating radiuses, getting a radius working. Really, really, really tricky. But this is a real benefit for you to take a look at. My hint is try to do all your radiuses in a sketch. Don't do it from geometry. Do it from a sketch. If you can control it from a sketch, you're one step ahead. It's a lot more simpler, but do take a look at that. Then once you get that running, the big one, this is a nice easy one. Nice easy one. Basic geometry. We have a cube with a hole diameter through the middle. What you could do is add restrictions to that to stop it so that people can't do a hole which is bigger than the actual cube. You could decide on a wall thickness with that. There's all sorts with that. But the big test on this one is this. This one is a huge pain in the backside. Try and make a loop which will allow you to design this and create this proportionally. So if I dropped that length to 800, what we'd like to see is them bosses being divided and moving into position gradually and moving correctly. There's many ways of doing it and many processes for doing it. A lot of the answers to that one in particular are in these notes. Do take a look. Because this one will help you if you're wanting to do scaled repetitive motions. This is where APIs really stand in its own right, but I do prompt you to have a good go at that. It's definitely worth doing, and it will teach you an awful lot. As ever, I will work through these solutions the week after for those who have the balls to have a go at it. Those of you who don't, just sit back, but those of you who do, I will work through this solution and you can compare yours to mine. And again, apologies for this recording. It didn't work out like I wanted it to yesterday, but today I will be filling in more of the blanks of the bits that we did yesterday, like working through the cube to boss extrusion solution from last week. Other than that, if there is any problems, there probably is problems, there's always problems. Do get in touch, drop me a line. I'm more than happy to try and help you. Those of you who've been having issues with things, errors coming up, things not running, do let me know, because this now tends to be uppercase characters. It can be a space where a space shouldn't be. It can be just misuse of, even right down to a spelling mistake. There's all these little bits and bobs like that. So do get in touch, and I can try and help you get moving along with that. Other than that, I shall speak to you all soon.